Okay, here are the notes for integrated to 2.1.2. I'm going to split it in two parts. So this is part A. So flowcharts for congruence. All right, if we take a look at this, just on the first sheet here, now some of this is, the majority of this is actually going to come from the framework of notes. I think I picked one question out of the book that I thought was good for us to go over. And these are reasons in a triangle congruence proof. So kind of have this at the ready for you whenever you're going through and doing the proofs. Make sure that you use what's given to you. That's the important thing. Moving on. All right, so steps to use in a triangle congruence proof. All right, so we're going to write the given, use the given until it or the statements following it leads you to a congruence statement. So we want that congruence. It's really a big key here. We want the congruence statement. Then remember to use the picture itself. So kind of like the stuff that you did last year with the vertical and reflexive. Again, you want a congruence statement. Then we're going to prove that the triangles are congruent. And now we've got that new thing as well. So the new thing is that we want to be able to prove parts. So sides or angle congruence ending with CPCTC, or you can do congruent triangles, give congruent parts. So that's another way. And then right here, we just kind of have the layout of how this looks. But please understand, this isn't like the hard and fast layout. This depends on the question itself. So we're going to take a look at some of those now. Okay, moving on. This is directly from the notes. I just reorganized it a little bit so that I could have more space on the slide itself, because we do want it all to be together. So if we take a look at the given statement, so I have this ASNCT, and then I've got this little marker there. So a little bit of a reminder from previous years, that marker, so the upside down, kind of looks like a capital T that's been flipped over, is perpendicular. As a reminder, perpendicular means that those two lines or line segments are intersecting, and where they intersect creates two 90-degree angles, so perpendicular. Now, if those lines were to continue, then all four of the angles that are created where those lines intersect, each of those angles is going to be 90 degrees. So we have a symbol, of a perpendicular symbol, but it is not a congruence symbol. So we're going to need to use that symbol, kind of look in the picture and see if we can figure out where that's actually going to happen. So I already color coded this green, so I may as well go ahead and use a couple green lines here, which I will end up probably extending, but I want to take a look at where AS, so I've got this line segment AS, and then I've got this line segment CT. Where those two intersect, so where those two hit each other, looks like it's at T, kind of in that ballpark. Those are going to be 90-degree angles. Okay, but we have to use what's given to us first. So first thing, take that statement of the AS line segment perpendicular to line segment CT. Where did we get that information? That information was given to us. Remember that your reasons go outside those bubbles, typically underneath them. Okay, so that's been given to us. Okay, now let's see if we can use that. Perpendicular means that each of the two angles, because I only see two in there at T itself, are going to be 90 degrees. So let's go back to the picture. So that means that the left-hand side where CT and AS are going to intersect is going to give me 90 degrees. So let's go ahead and put that inside the problem as well. So the left-hand side, you can't just call it angle T. There's too many of them. So we're going to trace it. So I think I'm going to call it CTA. You want to make sure that T is in the middle of the name. So I'm going to say that the measure of angle CTA is going to be equal to 90 degrees. And the reason why I know this is because this is the definition of perpendicular. Oof, getting a little tight there. Okay, now that's the left-hand side. Go back to the picture, we still need to do the right-hand side. So angle CTS So the measure of angle CTS is also going to be 90 degrees. For the exact same reason. So this is definition of perpendicular. Okay, that takes care of what does it mean to be perpendicular. Okay, then that means the two angles are going to be 90 degrees. However, if both of those angles are 90 degrees, then that means they're the exact same size. If they're the exact same size, then it means that those two angles are going to be congruent to each other. So notice that the arrows are kind of flowing down to the next bubble. So I've got the measure of CTA is 90, measure of CTS is 90. Okay, if they're both 90, then that means that they're both congruent to each other. We're going to lose the measurement part of it because we're not talking about that anymore. We're actually talking about the angles themselves. So CTA and CTS are congruent to each other. Well, that is the definition of congruence. If two things are the same size, then they're congruent to each other. Okay, so I think I'm at this point where I've exhausted all of that. I have created a congruence symbol. That was the key. Done. Check. All right, let's continue on. So I've handled the green stuff. All right, let's move on to the next one. So let's highlight this guy orange. Okay, that already has a congruence statement in it. So I am going to find another bubble on the same level. So here's what I mean by the same level. So kind of on the same level as those bubbles that I can write congruence statements with. So, and that is a congruence. So I know that I've got angle. So this was given to me. ACT is congruent to angle SCT. How did I know that? Well, it was given to me. Okay, I can mark it in the picture now. So once I have a congruence statement and I've set it in the proof, could have marked it in the picture and then put it in your proof, but you don't want to continue until your picture's marked up. It does help you, I promise. So ACT looks like this angle up here and SCT looks like that angle there. Okay, so we've done that. All right, now I'm at the prove part. Okay, I don't have enough information yet though. If you look at the picture, you only have two things marked. You know we have to have three. So now is extra vocabulary that I can look at and I can guarantee without a doubt is true. There's only two of them, and that's reflexive and vertical, so stuff back from integrated one. So in this case, the only thing that we have that we could still mark in the picture is that shared side length of CT right down the middle. So inside the other congruence bubble, so again, that same level here, we're going to go ahead and write that CT is congruent to itself. I know it sounds kind of funny, but we have to be able to introduce it. Then this is reflexive. Okay, now let's look at the picture. If I look at the picture, I have three things marked in each triangle. I think about the 5 things it could be. So side, 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 angle, side, angle, side, angle, 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 side, and HL. And I go through and I think about what I have. I have 2 angles, 1 side. 2 angles, 1 side. Oh. 2 angles, 1 side. Okay, it's got to be one of those two. And then I look to see where the side is. Well, the side is trapped between the 2 angles. So I do believe that this is going to be angle, side, angle. All right, so now I can take all of those and I can go down and prove the triangles themselves. Now, if you were super careful about how you named the angles previously, then you can just use the same name. So I think I'm just going to use the same order of ACT, so the bubble immediately above, except now I'm talking about the triangle SCT. And the reason that we chose for this was angle, side, angle, triangle, congruence. All right, now here's where the new stuff comes in. We're trying to prove that angle A is congruent to angle S. Now, if you have proven that the triangles are congruent, then all of the other parts that look like they should match do match. So if we look at the picture, and I ask myself, well, based off of the orientation of the triangles, does it look like A and S should match? Yes, absolutely it does. So in this last bubble on the bottom, I'm going to say angle A is congruent to angle S. Now that's because we have proven the triangles. So at this point, you could do congruent triangles, give congruent parts, or you could use CPCTC. I did warn you about CPCTC though, so just be careful with that. So that's our first like full-blown proof using some new stuff that we've used this year, but also using stuff that we've learned in the past. Okay, here we have another example. If it were me, I would pause it and see if you can kind of get this started at least. And then when you're ready to kind of come check back in, I'm going to slowly work through it again like I did on the previous one, but see if you can figure it out yourself. Okay, so here, I'm going to slowly start going through what's given to me. All right, so if I take a look at this, the first thing I have is that CA is going to be parallel, so I know what that marker means. It is going to be parallel to TS. All right, so that's not a congruence symbol, but it will help me get to a congruence symbol. So if CA is parallel to TS, so I'm just going to take a look at my picture for a second. So CA, putting my arrows on it, is parallel to TS. Okay, those are not congruence markers. However, if they are parallel, I know I'm going to have angles that match. So I'm going to go ahead and start with that in one of the bubbles. So CA is parallel to TS. I know this because it was given to me. Okay, let's see what we could extract from that. And I only have one bubble below it, so I only want to extract one thing. Well, I see alternate interior angles in here, and I see a couple of them. I think I'm going to stick with angle C and angle T. So I think I'm going to go ahead and mark that angle C is going to be congruent to angle T because they are alternate interior angles. Now, you could have done the other pair as well. You could have said angle A and angle S. So angle C is congruent to angle T. You'll notice that when I named this angle, these angles, I only used one letter. That's because it's clear what angle C is and it's clear what angle T is. Okay, so this is going to be alternate interior angles. Now, I could do the other angles, but I don't know if I need it. So I'm going to come back to that if I have to do it. So pull one of the angles out of there. All right, so now we know also that W is the midpoint of CT. Okay, we know what midpoint means. We'll get to that in a second, but this isn't currently written as a congruence statement, so we're going to have to use that to get us to a congruence statement. So all of that orange stuff is going to have to go in the bubble. So W is the midpoint of CT. I know this because it was given to me. Okay, so let's take a look at the picture. So W itself is the middle point for line segment CT, right there. Okay, if W is the middle point between C and T, well, if you're in the middle, then you have the same amount of information to the left as you do to the right, or top to bottom. So if this truly is midpoint, then that means that that line segment from W to C is going to be the same measure as from W to T. So I think that's going to go in my next bubble. So W to T is going to be congruent as W to C. How I know this? Well, it's because of the vocabulary word. I was told midpoint, so I'm using the definition of midpoint. Okay, let's see what else. Well, if you take a look at this last little bubble off to the right-hand side, so on that congruence row, so on this congruence row, there's nothing above this one leading into it. So that indicates to me that I'm either looking for reflexive or vertical, something I can extract from the picture without anybody giving me any information. Well, I think I've got vertical angles. So if I take a look at the picture, my vertical angle is going to be the top part of W and the bottom part of W. However, you can't just call it W. There's too much going on there. So I think I'm going to call one of them angle CWA. So that gives me the one on the top is congruent to, and then just be careful with your order. So I want CWA, so let's do TWS. How do I know that those are congruent to each other? Because they're vertical angles. And I marked it in my picture. Okay, I am now have all three of these congruent bubbles feeding down into the next bubble, which means I'm trying to say something about the triangles now. So hopefully I have enough information to determine that one of these is going to work, hopefully. If not, we may have to add some more bubbles. All right, so what do I have here marked in each triangle? I've got two angles and a side. Two angles and a side, two angles and a side. Okay, so two angles and a side, is the side trapped between them? Yeah, it is. So I think this is angle, side, angle. All right, so inside this, I'm gonna write my triangles. Now, I was super careful about how I named my vertical angle, so I'm just gonna use the same order. So CWA is congruent to triangle TWS. My reason? Oh, angle, side, angle. Looks like I lost my arrow here. Triangle, congruence. All right, let's move that arrow down. All right, so now go back. I've proven the triangles. Once you've proven the triangles, then basically the floodgates open. You can prove anything else that should match up. So I guess we need to take a look at the picture and see if CA line segment should match up with TS. And I think it does. So last bubble, we have CA line segment is congruent to TS line segment. If you prove that the triangles are congruent, then that means that all of the matching parts are going to have to be congruent. So you could say congruent triangles give congruent parts, or if you're feeling confident, you could do CPCTC. Okay, moving on. All right, now here's a problem from the book. This, so 2-15. And I like this one because the proof is already set up. Your job is to be able to fill in the reasons. So now that we've practiced a little bit with the reasons, I highly recommend pausing this one and see if you can fill it in. One of the things to keep in mind too is that although the given statements aren't written out, they are marked in the picture. So I'm going to use the picture to identify what my given statement is or statements are. So give it a pause, see if you can do this. Okay, so taking a look at this picture, I see that the arrows have been put on AD and CB. So I'm thinking that the fact that they are parallel has been given to me. So I think this first bubble is going to have a reason of given. Okay, that led to angle ADB, that's this angle here, and CBD, that angle there being congruent to each other. But notice that wasn't marked in the picture before. That was something I just put in, so it wasn't given. Why could they say that? Well, I think those are alternate interior angles. So my reason for this one is going to be alternate interior. Okay. All right, now I'm on the next row of stuff. So angle A and angle C. All right, I think those are marked in the picture already. So angle A and angle C being congruent. That means since they were already marked in the picture, this one is given. All right, then BD congruent to B. That's not marked in the picture. But if I mark it, I can see that that line segment is shared between both of the triangles. So this is reflexive. So notice all I'm doing is filling in the reasons. Okay, so now we're at triangles. So the dead giveaway, you want to look at the triangle symbol itself. Once you see the triangle symbol itself, you have your 5 choices. So you've got side, 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 angle, 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 side, and HL. All right, let's take a look at the picture. I've got 2 angles and 1 side marked in each picture. 2 angles, 1 side. All right, take a look at the side. Is it, so look in the triangle itself. Try to ignore the other one. Is the side trapped between the 2 angles? And I don't think so. I think this is angle, angle, side. So that's going to be our reason here. Angle, angle, side, triangle, congruence. And then the last thing is AB and CD. Okay, A, B, and CD. Not marked in the picture, but we did prove that the triangles were congruent, which means this is congruent triangles give congruent parts. Or you can use CPCTC. Now, CPCTC, just so we know, is corresponding parts of congruent triangles are congruent. It's kind of a mouthful. All right. And then moving on to our last slide. This is just a little bit of review on the idea of an isosceles triangle. So we did speak about this recently, isosceles triangle base angles. So a triangle is isosceles if and only if its bases are congruent. An if and only if statement basically means you could read this forwards or backwards and it's true. So for example, a triangle is isosceles if its base angles are congruent. Now read it backwards. If the base angles are congruent, then the triangle is isosceles. It's true both directions. This is a pretty powerful statement. So here we have our basic picture of, so in red, our basic picture of an isosceles triangle. Isosceles triangle, we've got the 2 legs matching, 2 base angles are matching. Okay, but now we've got case 1. And this starts introducing angle bisectors. So if we have an angle bisector WC is drawn, so what that means is that we're going to take this line segment that's been kind of put into the picture. It is called an angle bisector. What that means is that we are going to chop the angle in half. So an angle bisector, okay? And it's drawn to HWS. So let me get my color coding here. So if this is an angle bisector, then what happened was we created those 2 angles being the exact same size. If those 2 angles are the exact same size and WH, so down the side, and WS are congruent, then we can prove that angle H and angle S are also congruent to each other, because if you take a look at the picture, we know that we have angle side angle now with the angle bisector introduced. Then we've got case 2. So we're not going to go through and do these proofs, but I do want you to see that we technically do have enough information to prove. So case 2. We have if angle bisector WC is drawn to HWS, okay, and angle H is congruent to angle S, then we can prove that WH is congruent to WS. Actually, I think we will use these proofs, but we'll do them as warm-ups in class so that we can go through them together. But basically, an isosceles triangle is extremely powerful. Once you put the angle bisectors in, we should be able to prove that the 2 triangles that are now created inside the isosceles triangle are congruent.